This slide shows the chain rule. If g is differentiable at x and f is differentiable at g of x, then the composite function f is equal to f of g, defined by f of x is equal to f of g of x is differentiable at x, and f prime is given by the product. This slide shows the chain rule as well, but in Leibniz notation. If y is equal to f of u and u is equal to g of x are both differentiable functions, then dy over dx is equal to dy over du times du over dx. This slide shows the use of the chain rule, with the function f of x is equal to the square root of x squared plus 1. First, we will rewrite this function as x squared plus 1 to the 1/2. Therefore, f prime of x is equal to 1/2 the quantity x squared plus 1 to the negative 1/2 times the derivative of the inside function x squared plus 1. This will equal 1/2 times the quantity x squared plus 1 to the negative 1/2 times 2x. We will rewrite this as 1 over 2 times the square root x squared plus 1 times 2x, and simplify, equaling x over the square root x squared plus 1. We will also use the chain rule to take the derivative of this function y equals sine of x squared. If y is equal to sine of x squared, then the outer function is the sine function and the inner function is the squaring function. So the chain rule gives us dy over dx is equal to d over dx of sine of x squared. This is equal to the cosine of x squared times 2x. We will rewrite this as 2x times cosine of x squared. Now we will do a similar function, but note that sine of squared x is equal to sine of x squared. Here the outer function is the squaring function and the inner function is the sine function. Therefore dy dx is equal to d dx of sine x squared. This gives us 2 times the quantity sine x times cosine x. This slide shows the power rule combined with the chain rule. If n is any real number and u is equal to g of x is differentiable, then d over dx is equal to u to the nth power is equal to nu to the power of n minus 1 times du over dx. Alternatively, another notation is d over dx of the quantity g of x to the nth power is equal to n times the quantity g of x to the power of n minus 1 times g prime of x. Now we will differentiate the function y is equal to x cubed minus 1 to the 100th power. Taking u is equal to g of x, which is equal to x cubed minus 1, and n is equal to 100, we have dy over dx is equal to the derivative of x cubed minus 1 to the 100th power. This equals 100 times x cubed minus 1 to the 99th power times the derivative of x cubed minus 1. This will equal 100 times x cubed minus 1 to the 99th power times 3x squared. We will simplify this by saying 300 x squared times x cubed minus 1 to the 99th power. In this equation, we will differentiate f of x is equal to 1 over the cube root of x squared plus x plus 1. This will cause some difficulty, so we will first rewrite f of x is equal to x squared plus x plus 1 to the negative 1/3. Thus, f prime of x is equal to negative 1/3 times the quantity x squared plus x plus 1 to the negative 4/3 times the derivative of x squared plus x plus 1. This will give us the answer of negative 1/3 times the quantity x squared plus x plus 1 to the negative 4/3 times 2x plus 1. In this equation, we will find the derivative of the function g of t is equal to t minus 2 over 2t plus 1 all to the 9th power. We will be combining the power rule, the chain rule, and the quotient rule. Therefore, g prime of t is equal to 9 times the quantity t minus 2 over 2t plus 1 to the 8th power times the derivative of t minus 2 over 2t plus 1. This will equal 9 times the quantity t minus 2 over 2t plus 1 to the 8th power times the quantity 2t plus 1 times 1 minus 2 times the quantity t minus 2 all over 2t plus 1 squared. We get this from the quotient rule. Now we will simplify, equaling 45 times the quantity t minus 2 to the 8th power over 2t plus 1 to the 10th power. Now we will differentiate y is equal to 2x plus 1 to the 5th power times x cubed minus x plus 1 to the 4th power. In this example, we must use a product rule before using the chain rule. Therefore, dy over dx is equal to 2x plus 1 to the 5th power times the derivative of x cubed minus x plus 1 to the 4th power plus x cubed minus x plus 1 to the 4th power times the derivative of 2x plus 1 to the 5th power. This will equal 2x plus 1 to the 5th times 4 times the quantity x cubed minus x plus 1 cubed times the derivative of x cubed minus x plus 1 by the chain rule plus x cubed minus x plus 1 to the 4th times 5 times the quantity 2x plus 1 to the 4th power times the derivative of 2x plus 1 also because of the chain rule. This will equal 4 times 2x plus 1 to the 5th times quantity x cubed minus x plus 1 cubed times the quantity 3x squared minus 1 plus 5 times the quantity x cubed minus x plus 1 to the 4th power times the quantity 2x plus 1 to the 4th times 2. Now we will evaluate the function f of x is equal to sine of cosine of tan x. We will use the chain rule twice. F of x is equal to cosine of tan x times the derivative of cosine of tan x. That is the first time the chain rule was applied. This will equal to cosine of tan x times negative sine of tan x times the derivative of tan x. That is the second time the chain rule was applied. This will equal negative cosine of tan x times sine of tan x times secant squared x.